Ladies and gentlemen of Algebra 2 Honors, good afternoon. Good to have everybody here today. We're going to follow up on what we started on yesterday, and Ben, you weren't here for that, which was fitting quadratic functions to data. And we'll be using our calculator today and probably Friday. So here we have these problems 1 and 2. It says find an approximate quadratic model for the data by estimating the coordinates of the vertex and one other point, then sketch a graph of the model. What are some important key words in this explanation here, or instructions?
Vertex.
Vertex. Vertex and one other point. That's important. What else?
Quadratic model.
Quadratic model. That's important.
Estimating.
Yeah, the word I was looking for here was estimating. And I had a student, and did you say that?
No, that's...
Oh, Gabby. Yeah. Why is estimating important in this instance?
It doesn't have to be exact.
It doesn't have to be exact. And if you can see the way the data comes out, it's not going to be exact. You see points that are little anomalies, right? Like here in number 4. And so you're not going to have exactness. We had a student in 7th period, Bailey, who said that she was sort of troubled by sort of the squishiness of it, that they didn't have exactness. But fortunately or unfortunately, the real world, does the real world give us exactness? No, it doesn't. And so we're having to work with ambiguity and use our own judgment. And from person to person, are each one of us going to have the same judgment every time or things like this? No, we're not. And so as I go through problem 1, before we pick out someone for problem 2, I want you to just stay open-minded about it, just kind of work with me on it. So we're going to go take the vertex and one other point. What do you think would be a suitable vertex for problem number 1? And by the way, the graphics I have up here have more resolution than yours on your own paper just because of copying. What would be a suitable vertex up here, you think, for problem number 1? 5, 8. So 5, 8 would be one possibility, but I notice that I have this one over here at 6, 7, and I got this one over here at 2, 7. And based on that, I'm thinking a real vertex might be up here some other place. You're saying estimating the coordinates of a vertex. So what I did is I estimated a vertex up here of 4, 8.5. Now, if J had gone ahead, and if we used J's 5, 8, would we still have been good? Yeah. But maybe we would have not picked up this point over here very well, right? If we used 8, 5, our quadratic function would look something like this. But when we go over here to 4, 8.5, we have a better chance of at least picking up this point on the left, okay? But again, like I said earlier, it's a matter of judgment, isn't it? And if we went ahead, if J went ahead and you estimated 5, 8 as a vertex, would he be wrong? No, that's his estimate. And so as a mathematician, and for him, and actually this one might even possibly be better, because if you're more concerned about this data to the right part of the graph, then it would totally make sense to use what J suggests. But anyway, let's go ahead and work that out. So we have our standard form here, which is f of x equals a times x minus h squared plus k. And if we have this vertex here, what of 4, 8.5, what goes here? That's going to be equals, by the way. We're going to have f of x equals what? A times x 4 squared plus 8.5. And now it says one other point. So what's our one other point you want to use? I will tell you, between the classes today, there was pretty much unanimous consent over what that extra point should be.
8,
Yeah, and so it's what Jay said, 8.2. And why, Jay, did you pick 8.2?
That's one of the points.
Yeah, it's toward the end of the data. What it means is if we don't use 8.2, there's a possibility that this gets left out, and so it's not gonna, it may not look as good, right? And you could try something else, and you get an estimate. It might hit it exactly, but it may not. So by doing this, by going with the points farther away, we'll probably have a better chance of having a better fit, is what it amounts to. Okay? So just some things to think about. So now using that point, we can just plug in here, and we have 2 is equal to A times 8 minus 4 squared plus 8.5. And then, what next?
Would be
2 equals A 16.
Yeah, what I'm going to do is I'm going to do 2 things at once here. Abigail, I think you're right, but I'm going to subtract 8.5, and then also we have 16A, right? So 2 minus 8.5 is negative 6.5 equals 16A, right? And then so A is equal to
negative 6.5 over
6.5 over 16. Okay, and then from here, how would you write this as an equation? F of x equals negative 6.5 over 16. Okay, so we have x minus 4, is it?
Yeah.
Plus 8.5. One thing I saw this one here in other classes today, I saw this simplified to get out the integer here as like negative 13 over 32, right? And also I have like negative 0.40625 or something like that. So they could use any of these. I'm just gonna use this one right here, just because it's right here in front of us. So I go here, negative 6.5 over 16. We're going to have x minus, was it 4 squared plus 8.5. Oops, I put 8.55. Here we go. And what happened is I set up the window to match exactly the dimensions of the graph. So that's one thing you can do for emulation purposes if you have a chance to. And then you graph, you get this thing right here. And you see that we hit this 8.5, and then we hit right here this 8.2. And then is it going to hit this point right here? Because I also, remember Jay was talking about 8.5 or 5.8. Well, this almost hits 5.8. Looks like it hits above it. But then if we chose that, it would go like this, right? But here it is. So now we can just sketch in the graph here. So that's going to be, and what is our y-intercept? 2, according to this model. So I can go mark this here just to get another point. So we can just sketch like this. Okay? So that is going to be answer for us. What I want you to do is work on number 2, and I'm going to I'm going to choose somebody for number 2. I will tell you that I had people use different things for problem 2, but just use your own estimate and we'll call on somebody here.
Question.
Okay, let's go to our model here. Okay, we are going to choose someone here. Peyton is choosing. Peyton, we can, do you need to do it? You want to do it, Peyton?
Not really, but
You can? Okay. Whatever you want to do. You want to do it or not?
I'll try.
All right, Peyton. Good. All right, Peyton, what do we got for 2?
Vertex equals A, X minus 4 squared, 5.
X minus 4 squared plus
0.5.
0.5, okay.
And 7.5 equals A.
So what did you say, 7.5?
Yes, sir.
I don't, it says one other point, I don't see 7.5.
Yeah, that?
Yes,
This one here says
Oh, well, I
7.
can't see the line, so I just said something.
Okay, so 7 equals, that's what you meant, right?
yes,
So X minus, or it's going to be 9 minus what? 9 minus 4? Is that what you got?
sir.
Okay,
And so you subtract the 0.5 off. Or that's as far as I got.
okay, so we got 6.5 equals A, and that's going to be, what, 25? So A is equal to 6.5 over 25. Does that sound about right?
Yeah.
So what is our f of x going to be for this? F of x is equal to 6.5, or let me go ahead and, I'm going to write this as 13 over 50. just to get a non-decimal there. So 13/50ths. And we're going to have x minus 4 squared plus 0.5. Then test it out, see if it works. So 13 over 50, x minus 4, it was 4, wasn't it? And then we'll I'll just delete that. So that should be, is that, is something different?
I use the same numbers like I did.
Let's graph, see what it looks like here. Does it hit 4.5? Yeah. Does it hit 9.7?
I used different numbers and got the same answer.
Oh, really?
Oh, y'all did something weird too.
We didn't get, I didn't get 13.
Yeah, I got 6.5 over 25.
Because he, I did.
Yeah, he just changed.
You double this one?
Yeah,
Yeah.
it's the same thing.
Yeah, I just changed this to make it look neater. Instead of having a combination decimal and fraction, I just wanted to make this an integer over an integer. So I multiplied both numerator and denominator by 2.
Instead of 4 and 0.5 by Vertex, I use 4 and 0.
Use 4 as 0? Yeah, okay. So you got an answer for that? Okay, I want you to tell me where it is too. Okay, Jay says he used 4.0 for Vertex. Jay, that's a good job. Let's see. Jay, tell us what you got for your equation.
F of x equals 7 over 25,
7 over 25. Okay, put 7.
and then the rest was the same except for the 0.5 up there.
So plus 0. So what he has is x minus 4 squared, and then plus 0. So it's going to look like this. So we're going to see we'll see how J's match. I think it's going to match pretty well, the blue one. Does that match pretty well too, the blue one?
Yeah.
Yeah, it does. But see, these points here are like 5, 1 and 3, 1. So this one here is not going to match these over here. But look at the blue one matches all the other ones a lot closer, right? So it's a matter of what's important to you there. Let's see what kind of let's see what we got for y-intercept. Y-intercept we got of about 1, 2, 3, 4, about 4.5. So about 4.5 like this. Okay, so it'll look something like that. All right. Okay, I appreciate Peyton and Jay helping us out there. I want you to look at that and just think about it for a minute, and I'll go over this one for you. And Bryce was right. There was some controversy over this today.
Is this equation right here, Frank? This is the blue line.
Yeah, the blue one is what you did.
So
Was that
the
4?
vertex
For
is
her
whatever
13,
you
I got
think
the blue
is.
line, that's right.
Or did you, yeah. What you did is
Yeah,
use that
whatever
point
is
over there. That's what they use. Which is good. But you can see to the right, it matches quite well, but not as much to the left. So it's just better. But one thing that's good about using the one you did is that the arithmetic's a little easier too. So you have to look at it and just kind of weigh what's most important. That's the legitimate way to do it. Yeah, while you're looking at that, I want to show you what Riley had too, to bring something else to the fore. Okay, so Riley, you used 5, 1, right?
Yeah.
So So what Riley did is this. So what did you get for your fraction on that, Riley?
6/16.
6/16, so that'd be like 3/8, right? So 3/8,
Yeah.
and he got x minus 5 plus 1. So here's Riley's thing, the lavender one, right? So this is Riley's one. You see it picked up? And that, by the way, Riley, that's exactly what Bailey did in 7th period. So we got some different ways of looking at it. So I'm glad you did that. Okay. I'll just leave that up here since let me talk about 3. 3 is, as Bryce mentioned, there was some controversy over that today. And what this does, it brings up something called the factored form that I really haven't talked about much, if at all, in this class so far. And the factored form is this. You have f of x is equal to a times x minus, I'll say x minus p times x minus q. But in this case, p and q are the x-intercepts. All right? So I put those different letters up there because we're really talking about something different. So what are going to be your x-intercepts for this equation right here? For this function? What are your x-intercepts here? So what you could say is x equals 1.5, could be one of them. What's another possible x-intercept? Yeah, 9.5? Or I'm thinking maybe like 9.2. And when you have the zeros, you can use those to find factors. What do you have to have factors? They have to be zeros. And what do you have to do to make these factors out of these zeros? Any ideas? Well, you have to solve these equations for 0. So to have 0 on the right side, what are you going to have? Well, you're going to have x minus 1.5 is equal to 0. And so this x minus 1.5 ends up being one of your factors. And similarly, here for this other one, you're going to have x minus 9.2 is equal to 0. So this is your another factor. And so these are the factors that we're going to use plus one other point. So let's go, I want to just go ahead and write these in factor form so far. I have f of x is equal to a times quantity x minus 1.5 times quantity x minus 9.2. Okay, what do we have to do next? Find or use? One other point. What's the one other point you want to use?
Let's go with 5/8.
5/8? Yeah, 5/8, that's what the other classes have used, and again, it has the benefit of knowing that it's going to go through here. So if we use 5/8, so that's going to be, is it 8 equals a, and then we're going to have 5 minus 1.5, right? And 5 minus 9.2. So we can go to our calculator. 5, and I just happen to have worked this out for the last class. So if we have 5 minus 1.5 times 5 minus 9.2, we get negative 14.7. So 8 equals negative 14.7a. So what is a equal to? A is equal to negative 8 over 14.7. And you can go ahead and work this out and get a decimalized version. But now we have an equation that can be worked out, which is f of x is equal to negative 8 over 14.7 times x minus 1.5 and x minus 9.2. Now, if there was controversy, which there was during second period, it's because I happen to put a k outside here. Well, in this version, a k is not really necessary. You don't have a, it's a different thing altogether. So we can go take our calculator and see if that's going to work. Is it going to work? Should. So I'm going to go here and just do this blue one. I'll put negative 8 over 14.7. And then over here I'm going to put x minus 1.5 x minus 9.2, and just like that, delete that one out. And then I'll go down here and delete these guys too. Clear, clear. So now we'll see if it matches okay. It should hit the X-intercepts. My main question is, going to hit the 5/8. Is it going to do that? Well, let's graph and see. See, it hits the X-intercepts, and does it hit 5/8? Or, yeah, it does, right? Perfectly. And you can see the vertex is just faintly to the right of that. And we can find what the maximum is, or we can go second trace maximum. And it has this little cursor here. It says left bound, press enter. And we go to the right, press enter twice. So we get at 5.35, we have a maximum of like about 8.07. So it's going to be just right over here. So the thing's going to look like this. Okay? What I want you to do is number 4, and I'll pick somebody to help out with number 4 here in just a few minutes.
Is number 4 and number 6 the same one?
Let's look at that. I'm not sure. It looks the same, doesn't it? Yeah. 8, 9, 2. Yeah, it looks like it's the same thing, pretty much. So we should get to that maybe on Friday.
What, number 6?
Yeah, we should get to 6 and number 5, which is related to number 4. That's a good observation.
Can I put your back?
Yeah. Go to it, yeah, go. So tomorrow is a JV football game scheduled, right?
Mm-hmm.
Is it still on as far as you know?
No, it's not.
It's off?
Yes, sir, there's no game tomorrow.
No game tomorrow?
It's negative, it's negative.
I think it's two. I don't know.
Works on the grass again.
No, the grass is on the grass. School grass on the grass. People was playing in the grass for a long time, so there wasn't there. It is the one, because I used to last year.
The game was faster.
Only because I have a wide.
Okay, I'm going to choose somebody for 4. Okay, number 4.
You're gonna have to repeat.
Oh, yeah, Jaden.
I always get picked on the hard.
Well, that's good for you, Jade. That's how you'll do it. This is karma dishing you up something that benefits you. That's what's happening here. All right, Jade, what do we got for this one?
I went ahead and I chose like the vertex to be 5.5 and negative 5.5.
Okay, the deal is find X-intercepts here, right? What X-intercepts did you choose?
Oh, okay, I didn't read that part. X-intercepts would be 1.50.
Okay, that looks pretty good.
8.5.
Maybe 8.5, okay. So X equals 1.5. X is equal to 8.5. And what would our requisite factors be from that?
Or what?
What factors do you get out of those zeros? Subtract 1.5. We get X minus 1.5 is equal to 0. And what do we get over here?
Be X minus 8.5 is equal to 0.
Yeah. So now we can go ahead and what's this we'd have f of x is equal to a times x minus 1.5 x minus 8.5. So what other point did you use here? Okay.
5.5 and negative 5. Wait.
What?
I was just going for the vertex, so what other point would we look for?
One other point.
Oh, okay.
So you're looking for another point that
Gotcha.
should be representative for you.
1, 1.
1, 1?
Yes, sir.
Okay, that looks like that's probably a pretty good one. So if we use 1, 1, anybody else use 1, 1? You did? Okay, Marcus did. Who used this one, 9, 3? Anybody use 9, 3? Yeah, Ben did. So it's really, you can do what you want here, right? But what's going to be convenient about 1, 1?
It's easy.
It'll make the arithmetic pretty simple, right? So here we have 1 is equal to A, then we have 1 minus 1.5 times 1 minus 8.5, right?
Yep.
So 1 so you have 1 minus 1.5, 1 minus 8.5. So we get 3.75, right?
Yep. 3.75 A.
So A is equal to
That.
A is equal to 1 over 3.75. And so what is our equation going to be?
F of X is equal to 1 over 3.75 X minus 1.5 and X minus 8.5.
Okay. Now, I hope you see that Jaden, he was caught a little bit flat-footed on there, but what did he do? He just went with it, right? So we can do that.
I use different numbers again.
Oh, did you? Okay. Well, we'll just kind of see how well it fits here. So what do you have? 1, you said? 1 over 3.75. And then here we have x minus 1.5, and then x minus, was it 8.5?
Yeah.
We should get it just fine, shouldn't it? So graph. And we don't see the same dimensions of the graph. I'm going to go ahead and look at the table here, look at the graph. We're going from -6 to 4. Okay, so I'm going to change that a little bit. So -6 to 4. And we graph that, we should get, does that look pretty good?
Sure.
Yeah, it does. We have a y-intercept of a little over 3. So a little over 3 right here, so the thing's going to go like this. Okay, so we'll leave it there and come back, and probably we'll zoom on this on Friday, and we'll probably work on factoring tomorrow is my guess. Thanks.